Hello students, today's video we will be learning about refraction of light through a spherical lens. So before we go further, let us understand what are spherical lenses. Why do we call them spherical lenses? Imagine that this one is a sphere, and if you cut this portion, then which shape lens you will get? You will get biconvex lens. Okay, just imagine from this person which kind of lens you will get. You will be getting biconcave lens. So if I would like to simplify two spheres, let us keep them in vicinity and let's just imagine. If I cut from here and from here, these two lenses which we will get, from here also we will get biconvex, from this portion also we will get biconvex, and from this we will be getting a biconcave lens. So this one is convex, and this one is biconcave lens. So I hope you have got it. Since they are derived from spherical structures, we call them biconcave and biconvex, and in general we call them spherical lenses. Let us learn some of the important terms related to them. Here also in figure you can see this is the center of the sphere, from this end also. So if I draw a line here, you will find, let us imagine that the center of this part is this one. So this will become center of curvature. This one will be considered optical center. Similarly, suppose this one is one face and its center is, let us say here, C, then that will be the C, and this one will be considered optical center. Now let us understand some important terms. So we are going to study now terms related to spherical lenses. First important term that you find, principal axis. What is principal axis? This is a line passing through optical center and center of curvature of a spherical lens. Let us say this one is a biconvex lens. So line passing through is this. So this one will be considered principal axis. Now there is another important term, that is principal focus. principal focus is the point on the principal axis. The point on the principal axis at which parallel rays meet or appear to meet after refraction. You just see. Sometimes confusion arises when people talk about first principal focus of a spherical lens. There you have to have clear idea that it is the point on the principal axis, that is first focus, from where if the rays emerge towards a lens and after refraction they become parallel. Now, similarly, in case of biconcave lens, if a ray is focused through its focus, but after refraction it becomes parallel. So in terms of, if I say for with reference to this, if biconvex lens, if I say it is the point on the principal axis from where if the light rays emerge and are exposed to a biconvex lens, after refraction they become parallel to the principal axis. So that point is first focus, principal focus. In case of biconcave lens, if the ray of light is exposed towards the focus or towards, let us not say focus, towards the biconcave lens, and after refraction it passes parallel, then the point on the principal axis will be considered first focus. Now, this is, I hope it is clear. Let us now discuss about center of curvature. Here, the distance between principal focus and optical center is called focal length. So in short, I would write here that small f represents focal length and capital F represents principal focus. Okay. Let us move further. Okay, let's move further. That is center of curvature. Center of curvature is the point on the principal axis of which spherical lens is a part of. If I say, let me show, this one is sphere, and let us say this portion is spherical lens, convex lens. and let us say this point is the center. So for this face, this is the center, and let us ignore this distance. This distance is negligible. So this is called optical center. And now you have understood. So this is optical center. Distance between O and C we call radius. So here we will call it radius of curvature. R means a radius of curvature. Curvature means part of curve it is. Now, very important thing that we have, that is relation between radius of curvature and focal length. Always remember that if we consider in case of biconvex lens, then always focus will be at the center between the O and C. So if this one is R, radius of curvature, then this one is focal length. So in other words, we can say that focal length is always half of the radius of curvature. Now we will be talking about rules related to the ray diagrams associated with spherical lenses. Let's see the rules. Rules for a ray diagram. First one, a ray parallel to principal axis passes through principal focus after refraction and vice versa. Suppose there is a ray which is passing parallel, then it will pass through principal focus. Now, reverse is also possible. Suppose a ray is there which is passing through principal focus. After refraction, it will pass parallel. Similarly, in case of concave lens also you can consider. If the rays are parallel, it will diverge, but if you extend it backward, it will pass through principal focus. Again, but if the rays are passing through principal focus, then it will appear to pass parallel after refraction. This is the first rule. Second rule we have, a ray passing through optical center passes undeviated through a spherical lens. Let us understand this with the diagram. If a ray is passing through optical center, it will pass straight. This happens even in case of biconcave lens. If it is passing through optical center, means it will pass undeviated. There is third rule. Okay, in general you have to believe that spherical lens behaves like a set of prisms that it has. Let us consider in case of prism what happens. In a spherical lens, has a number of prisms. And always remember, suppose this one is a biconvex lens. So if I cut here, it behaves like a prism. And always remember, light rays, if they are coming parallel, they will bend towards the broader base of a prism. So you can see the first triangular block here, if we see, then if the rays are coming parallel, they will try to bend towards the broader base and hence they bend. If I magnify and show this one, then I will say that let us make little bigger one to make it very clear. First the rays come, they bend, and they bend further and they meet at the principal focus. So it is behaving like a prism. Always remember, light rays in a prism, light rays always bend towards broader base. This is very, very important that you have to understand. Always bends towards the broader base. So these are the rules that we have learned related to refraction of light through a spherical lens. So here I conclude this video, and in next video we will be talking about how the rays, how the images are formed at different positions when light passes through a lens at different positions, and what are the characteristics. Thank you for watching this video.